Wow, hello, thank you all for being here. Today we're going to explore progressive web apps and how they actually fit really well into Rails. I'm going to show you a demo of a progressive web app I made that was very fast and responsive and was built only with a Rails stack, no front-end JavaScript other than some stimulus. My name is John Beatty. I'm from Loudoun County, Virginia, in the suburbs of Washington, D.C. We live about 8 miles from West Virginia, a state described as almost heaven. So I like to say that we're almost heaven. We're also 8 miles from the cloud, literally. Amazon's US East 1 is just down the road, and I even use the local cloud to access the internet. This is my children accessing the Netflix cloud. My Rails developer story starts with actually developing iOS, Android, and BlackBerry apps in 2010. I quickly learned that those apps needed a back-end service to manage the data that shows up in an app. And at this point, I was young and my time was cheap, so I learned Rails to build those backends. And I fell in love with Rails, and I found that it matched how iOS apps were developed, even down to some of the small talk similarities between Objective-C and Ruby. And in the meantime, I worked at a few startups in the DC area and on my own for a little bit. Then an opportunity to teach and run the IT infrastructure at a school came up about 5 years ago, which took me out of the technology hamster wheel. But there, I kind of morphed the job into an embedded software engineer. So I've actually been building a school management system from scratch that we use to manage student records and things. And this has allowed me to experiment with a lot of Rails features to see where they can be used effectively. And I currently blog about stimulus.js and building responsive and interactive websites at my blog, johnbeatty.co. But enough about me. I want to talk about what you guys are going to get out of this. I would like you to walk away from this talk as sort of progressive web app badasses. I want you to be able to not need to hand-wave your way out of a conversation about progressive web apps. I think there's a lot of confusion about it, and especially how it can fit into a Rails stack. So I want you to be able to advocate for using the full Rails stack when you're building a fully interactive and fast web app without resorting to something.js on top of a Rails API. And so I'm going to show you one way I've done this with a version of the Hacker News progressive web app that I built using only Rails, and I'll talk about more about that. So to start, I want to set up a kind of a common vocabulary that we can talk about progressive web apps, and this will help make sure that we're all on the same page and sort of understand and cut through the fog that's out there. So the most important thing is you can think of a progressive web app really as a convention. It's very simple, and you just need to add a couple files to your app, and a browser will treat it as a progressive web app. All you need is an HTML page, a JSON manifest file linked to from that page, and a JavaScript service worker that is loaded from that page. And there's a little bit more to that, but that's the essential part. It's just those 3 components. So as an example, just where we can start from, this is what your head of your index page would look like. You'll note that there's a link to the manifest file with a little rel tag as manifest. We need to set the viewport so that it appears properly on all screens, especially those compact mobile screens. And then you can add a theme color, which will be part of the loading splash screen if someone actually installs it as a full-time app. And in the body of that HTML page is real simple. I just have a title and a paragraph, and then a little bit of JavaScript to load in a service worker from our web page. And this is, we register it with the scope of whatever the web page is, usually the full scope of your application. And then that's truly all you need for the HTML part of this. The manifest file is also pretty simple. It's just a JSON file. It contains some metadata for the browser, such as the app name and some app icons that will show up if they install it, or if your customer installs it. It will also set up the scope of the progressive web app, so you can think of that as the root folder that everything works from. And this metadata is similar to what you would put on a mobile app, such as the name and the icons. And then lastly, the service worker. There are a few callbacks that the service worker needs in order to work properly. And this JavaScript worker is also a convention. It's one where the browser starts running a piece of JavaScript code, and this code waits for the events to fire, which it handles. So here's the first callback. It's the installation callback, which will be used to cache those files that you would want offline. At the very least, you can cache a special offline page. You don't really have to cache anything if you don't want to. Later on, we'll use this part to cache some of our Webpacker assets and any files that we think should be available when the web browser is offline. This is the service worker activation callback. You can use it for a bunch of things. Here, it's managing the state of the app caches, clearing out those stale caches that are no longer needed. And then finally, this is kind of where this service worker fetch callback, this is where the web app, progressive web app really shines. Every single request goes through this function, and this callback decides how to handle that. Here, it's trying to retrieve each request over the network. Then if that fails, it tries to retrieve the file out of the cache. And if that fails, and it's an HTML request, in this case, the worker is going to load the offline page that we cached previously. There's a Mozilla Service Worker reference page that I linked to later on in the talk that has a lot more examples of what you can do in this callback. So this is a really simple example, and there's a lot more powerful things you can do here. And then finally, we've got these functions. We have to register them so that they actually get called on these events. And that's it. That's 3 files, and you have a valid progressive web app. And I'll show you that's truly the case. Some resources that you can look into is Microsoft has a PWA builder. It's a nifty tool that will look at an existing site, generate a manifest and service worker files, and you can actually check some boxes for things you want. And you can find this at pwabuilder.com. And then Mozilla has a service worker cookbook with many examples of different service worker techniques, including caching content and web notifications. So I'd highly recommend you checking that out at serviceworker.rs. Google, built into Chrome, has a really nice audit feature that will test for performance, progressive web app, set up accessibility and best practices on your page. It's in the developer tools. I think you click audits, and then it's one of those things you can test for mobile networks, like slow 3G connections, latency, things like that. And then finally, to really put some code behind my claim that this is truly a progressive web app and that it's really just a simple convention, I wrote the world's fastest PWA, and you can get the source code on GitHub if you like. But like I said, on Google's Lighthouse audit, which is great for testing these kind of things, got 100 out of hundreds, so very fast. And then these are just the files for it. It's got 2 icon files that are required for the PWA. It's got our index.html file, our manifest.json, our offline.html that will show when the page is offline, and then the service worker. And that's just all that stuff from the previous slides. And so with these files, you can get it on github.io, johnbeatty.github.io/worldsfastestpwa, and you can see it yourself. And then if you load it, turn your browser off, or your Wi-Fi off, and then refresh it, you'll get the offline page too. So really simple to start with. So why should we care about this new convention? As I said before, I got into Rails by writing backends for my iOS apps. And anytime I told someone that I wrote iOS apps, they would tell me all of their great app ideas. And I think we all had that great idea at some point, honestly. You know, we were all going to make $1 million. And I found myself that I often worked on apps that were really just a wrapper around some kind of website content. Some of them were more complicated and truly needed to be native, but a lot of times it was just pulling in RSS data and just sort of displaying that natively. So these weren't really games, but a native presence helped in some aspect. And I imagine some use cases would be like if you're a restaurant, your avid customers would appreciate the menu loading instantly after they've already browsed it the first time, so repeat customers. And I think progressive web apps can negate the need for many types of these native app wrappers. You can get offline support, and on Android you can get notifications. And actually on Mac OS, on Safari, you can also get notifications. It's a little trickier, but most importantly, you got a canvas that you can build an app on that looks like a native app. And if we can make an app look like a native app and feel like a native app, isn't it really a native app? And so we're going to do this. We're going to delight our customers, and we're going to need to match the perceived speed of a native app. And we've seen some of the simple things we need to do to make something a progressive web app, such as the JSON manifest, the service worker. But in order to really delight these customers, we need to have more than just those 3 text files. So I propose that we can use Rails default components to build these fast websites. We can sprinkle stimulus on the front end for interactivity. We can use ActionCable for out-of-band communication between the app and the front end. We can use ActiveJob to do little or large bits of work in the background. And we can use Russian doll caching everywhere so that the background HTML rendering can be reused every time a page loads. So nothing fancy, just vanilla Rails. And I put together a demo, and it's based off this Hacker News progressive web app specification. And this demo is built, like I said, entirely from Rails. And so by combining all these components and these techniques in the standard way that we read on all these other blog posts, I again was able to produce a website that scored a 100 on Google's Lighthouse test while being deployed in production, and at the same time being a fairly interactive progressive web app. So for this Hacker News progressive web app, the data is going to load in the background, and the pages that people get on their browsers or everywhere in their phones or their desktops, they're going to load really quickly. And then they'll be updated in the as the API in the background is refreshed. So I've got the source code on GitHub you can look at. I wasn't able to clean up as much as I like, so forgive me on that. But it's all available, and you can kind of get an idea for how you might structure an app like this. But before I want to dig into those details, one thing that comes back from my time as an iOS developer is that there's one theme that we always talked about developing iOS, just to make sure that our native apps are really interactive. So in the iOS and Android world, every app has a main thread, which is kind of what everything's running in. And then for those apps that loaded data over the network, there was sort of a rule of thumb that you never wanted to block the main thread, which means you didn't want to pause the app somehow to load the data. You wanted things to feel very smooth. And I think our web apps can adopt this rule, and I can do it really well. And especially if we're going to compete with these mobile apps that are just wrappers around websites. So we have to remember that native apps are using the same spotty cell networks, and if we can put on the air of being fast while loading something very quickly, and then letting data fill in as it's available over a WebSocket connection, we can compete really well with these native apps and what they provide. And again, this works really well in Rails, as I'll show you. Just to reiterate, Turbolinks is going to help by keeping the JavaScript and the CSS parsed, so it doesn't need to be re-rendered and loaded every time the web page refreshes. And that means that we're really only waiting for just HTML to come over the wire. Any tasks that might slow down a web page and really can't be cached, like accessing another API, we can put those in ActiveJob. And then once we get the results that we need, we just send that over ActionCable to the front end. The service worker is also going to help in this case because it can cache those pages that were already visited. There's a technique on that service worker, Mozilla Service Workers page, where you can load a page from the cache locally, send a network request to get a newer version, and then load in the new page when it arrives, which is similar to what Turbolinks does. So it's another caching mechanism. So now I present the Hacker News progressive web app built with Rails. So the Hacker News progressive web app so I came across it just doing some research one day. It was in a conversation discussing what kind of sample project someone could work on if they wanted to build something that was really interactive and learn a front-end framework. There's a whole lot of examples other people have done in Angular, Vue.js. So I looked at this and I thought, well, I wonder if I could build something like this in Rails. I thought this would be a great personal project, and especially since it's using some of these cutting-edge browser technologies. So the idea of the Hacker News progressive web app is it's sort of something that builds on top of the idea of this to-do MVC project, where if you come up with a specification that is pretty technically complicated, but it's standard, then you can have many people build their own implementations for this specification, and you can see how you can use different tools to solve the same problems. And this was what I wanted to do was prove that Rails could perform just as well as any front-end framework in building a fast and interactive website. So this was a good benchmark. And this was the result of it. This is at my website, hnpwa.johnbeatty.co. It's using this Bulma framework as a CSS theme, and it's currently running Rails 6, and it's pulling data from the Hacker News API. And then just getting back to the performance, again, it scores really well because it's doing a lot of the techniques that are recommended when you're using Rails, the caching, where it's served over Passenger through Nginx. All the assets are cached and gzipped and everything, so it performs pretty well. There's another test that the Hacker News Progressive Web App spec wants you to test against, which is over spotty 3G connections. They call it the Emerging Markets Mobile Test. So this is a really slow 3G connection over on a cell phone. And again, it does really well in order to make this interactive. So the data that it comes into this app is this Hacker News API. There's a specification on GitHub for this too. There are 5 endpoints that we pull the data from, and basically you're pulling a bunch of different items in a bunch of different categories, and then loading the details for those items and displaying them in a nice format. The Hacker News API really has 2 models. One of them is an item, which is kind of what everything comes in is, jobs, stories, polls, comments, everything is an item, and it has all the displayable information we really care about, such as the title, any text associated with it, the author, any child or parent relationships when you're talking about comments. And then there's a user model that has the username of the person who commented, or is it a Hacker News user, and then some biographical details. So a very simple data model. And what I did was rejiggered it a little bit to work better with how we were going to design this Rails app. So everything that comes into the app is an item and gets a record as an item. And then there are 5 different categories that are sort of sub or associated records with these. So an item could be both a new item and a top item, depending on how it works in the system, or it could be a top item and a show item. So that's every item could be part of one of these categories, which is why they're separate models. So top stories have a corresponding top item, and new stories have a corresponding new item all the way down the line. One thing that those parent records have is they also keep track of the location where things come in the list. So each of those categories, when we hit the endpoint, you just get the IDs in an order, and you want to keep that order in order to match what the specification wants. So that's another reason for having this separate category relating to an item. This allows us to move the items as they change in position, depending on how they're voted on or how they appear, or they get cycled out of the Hacker News web feed. And then a lot of these items have a parent-child relationship, especially in regards to comments. So if you have the story is usually the parent item, and then it will have many comments below it, and those comments can have comments, and you can kind of keep going down all the way. So there's all these items have a parent and a child relationship associated with them. And then the web page itself basically is 5 different top feeds that we had to match. There's a /top, which is all the top stories. That goes to the top stories API. And the news stories goes to the news stories API all the way down. And each one of these is actually going to be loaded in an ActiveJob in the background. We're not going to do any of the API loading and any of the controllers because we don't want the page to feel slow when they load it for the first time. So as an example, the top page will go to the top stories endpoint, and it will get back up to 500 different IDs, all in order from 0 to 499. And then after that, we need to make 500 distinct requests to the Hacker News API to get the details associated with each of these IDs. There's no sort of way to get them all in one big batch, which is another reason why putting these in background jobs is great, because if one of these jobs fails, it can be restarted if we set it up with something like Sidekick or some other service that will manage our background jobs. And then each one of those items, we start a second job that will fetch all the details. And I think this highlights the theme that I talked about before of trying not to block the main thread. if you imagine trying to load all the top items, even if it was just 32, but on that one controller request, how many seconds, that could probably be a couple minutes to load everything in and then display an HTML page. So by putting things that should be in the background, and then eventually we'll send the data to the front end, we can actually get a lot better performance and delight our customers. So this is the ActiveJob. It's real straightforward. It's an HTTP GET to the API. It gets the JSON, and it's an array of items, and it just goes one by one with the IDs and their location, and then spawns subjobs that will actually get the information. And then there's a little mechanism, because that number that we get back of top items isn't always the same. We destroy the items that are no longer part of the JSON API, or Then, in order to get each of the items themselves, these all come in a load top item job, which gets the details of the item, stores that result in a record, and then also creates or updates the existing type item that refers back to the item we have, and updates the location if that's the case. One of the great things about this too is that since we're going to eventually put the items into ActionCable and send them to the front end, there's going to be some caching that happens in this background job, so that when people go and visit the front page, just as a regular browser request, there's no need to re-render all those items. They're already in our cache of HTML items. And then again, we repeat this for the load new items, the load show items, the load ask items, and the load job items. And so this is the code. I cut out a little bit of it around the populating the item. But we're going to the API, getting the data back as a JSON feed. It gets stuck into an active record model for the item and an associated top item. And then we just push those changes over ActionCable to whoever is listening. And the rendering there in the message that we send is, again, going to render that HTML and then also store that data in the cache so it's used elsewhere. So one great thing about this setup is that everything is rendered in server-side in HTML. There's no need for any formatting on the front end. And we're aggressively using the Russian doll caching strategy. So even though theoretically there's a bunch of n+1 queries in here, because we're doing a lot of the caching, that doesn't affect the performance of the page render. So here's, again, the top news controller, and this pattern repeats for all the other 5 categories. But we've got the same. We've got a page that is passed as a parameter, so we can do some pagination. The page starts at 0. We load 32 items for every page that we've seen. We get the top item that was most recently updated that we use for caching on the front end. And then we load the items. And then on the show HTML file, here we're just, again, doing caching on the news list, the top item, and the page, so that each page has its own specific cache and there's no duplicates or problems like that. And then we're slicing them into each of the top items and rendering those. And then each of those top items itself is cached, and it drops in a little metadata that is used later by Stimulus in order to set up the ActionCable. That data location field is used there. And then we just render the item. Because so many things can use the item, we're reusing that item all throughout the app. And then the item itself, I edited it for brevity, but we again have another data item ID metadata that were used by Stimulus when it's getting results back from ActionCable and then appending them to the HTML. And then again, this item is cached too. So that's 3 layers of caching. And since we're pre-rendering a lot of these partials in the background on API fetches, we're going to get really solid performance on this. So aggressively caching the content allows us to keep true to our don't block the main thread theme. Memcache can load these pages really quickly without many database queries. And this is going to make everything feel faster. Even though we know there's a lot of work happening in the background, we want it to feel really fast. The refreshing data that happens in real time is going to be sent over the WebSocket connection over ActionCable. And as items are updated in the background, we just broadcast them to anyone who's listening. And on each page, we'll go back to it, but there are a bunch of different controllers, stimulus controllers that are going to manage those ActionCable connections. The stimulus controller will subscribe to either, there's actually two listenings for each of those items. One for the individual item if it updates, because it could update elsewhere for other categories, and then since it's on this one page, we'll just refresh it with the most recent data. And then also, we're going to listen for updates on the locations of where they are. So the top location, index 0, we're listening for changes to that, and index 1 all the way down to the end. So because this is all happening in the background and then the person is just looking at their page and it's changing in real time, it does feel very interactive, even though we know that it's really just sending HTML over WebSocket connections. So as I said, the stimulus controllers are going to manage connecting to those ActionCable channels. I've got some annotations on this page. This is something I took out of the show, the top show from previous slides, but we've got an item location controller, stimulus controller, that is going to use the data location attribute on each of the top items in our page. And then in the controller itself, when we, this is the first half of the item location stimulus controller, it's going to take the channel name data attribute, which was over here in the section, and then start a channel over ActionCable based on that field we give it. This setup this setup that I have right here is used to handle the case where a page is either reloaded or a page is visited from another page, and TurboScript didn't reload the whole JavaScript, all the JavaScript code we have. So there are two different ways that you could get this thing connected, and this setup handles both of those situations. And then on the bottom in the received part of this channel, when the message is received, it's just going to replace the existing HTML on the page with a brand new HTML. I imagine if you wanted to have some fancy animations and things, you could put that in the CSS, but just to kind of show you what, that you can just replace the HTML without any of that. This is the second half of the stimulus controller. So here, again, in the connect call for the controller, it will attempt to listen onto the ActionCable connection, and if it's set up, it will subscribe, and if it hasn't been set up, then it just kind of doesn't happen, and then the initialized call for the controller here takes care of creating the channel. And then when the stimulus controller is disconnected, like if the page refreshes, if we move to another page, this is going to send the unfollow command to the ActionCable channel, and we'll actually stop streaming anything to this page, so we won't send any extraneous data. And then finally here, we've got a listen function at the bottom. This is the one where it goes through all the data location and gets the locations of the page that we're concerned about. So if we're on the first page, it would be 0 through 31. If we're on the second page, 32 through 63, et cetera, et cetera. It gets all those numbers, those IDs, puts them into a little array, and then calls the follow command on the channel and sends those locations. And then on the ActionCable side, it will, when the follow command is called, it takes the locations that are passed to it and sets up a stream for each one of those locations. And when the ActiveJob is loading the data, it will send it on whatever the top item channel is related to this. And then unfollow will stop all the streams. Okay, so that's how we built a really interactive website. Now we got to kind of make this a PWA to satisfy the needs that this is an app. I think there are many ways you could probably do this. This is one way that I found worked pretty well. I think it works because I wanted to be able to cache all the Webpacker assets. So I wanted to be able to use ERB and the asset helpers in order to put those URLs in there. And then any images too, those things will come in there. And so what happens is how I did this is I built a single purpose controller. And I set up some routes for the service worker and the manifest file in my Rails app. And then I added the templates that I needed. And in those templates, then I can use since they're ERB, I can put in any of the routes that I need. And then since these aren't supposed to be cached, these have to become, we want these to be fresh every time the browser asks for them. I don't think it made sense to put them in the other asset pipeline locations. So those are some of the reasons they were put in their own controller. So in the routes file, I've got 3 different routes, one for the service worker, one for the manifest, and one for the offline file. And they all go to the service worker controller. The service worker controller in this case doesn't do a whole lot. The only one thing it needed was to remove the protect from forgery for the service worker. It had something to do with because it's a JavaScript file. Google Chrome wasn't happy. And then this is my manifest.json.erb file. And you'll note that the asset path for the icon means that we can use the asset pipeline. The start URL and the scope, we can set those as with our URL helpers. So that's one advantage of them being actual templates in our app as opposed to hand-coded assets. Then this is on the service worker side. I just have the uninstall because that's all it was really needed. But here I can cache the assets from Webpack without having to hand code whatever that SHA is at the end. So this saves a lot of work. And then whatever files you can also put in here that you need. In this situation, I just wanted the JavaScript, the CSS, and the offline file so that when it's not, when your browser's not online, everything looks really nice and crisp. So that's it. That's how you can build a really fast app that rivals any front-end JavaScript. Again, we're leveraging turbolinks, so our app is really only sending HTML over the wire after that first load. And this really isn't different from any other app, any other web app that has to load all of its resources in, and it would only talk to a JSON API. Text over the wire is text over the wire, whether it's HTML or JSON. So we're going to get the same performance that any of those front-end frameworks would have. The Russian doll caching is going to mean that each request won't need to be re-rendered every time. We'll save a lot of database calls by reusing existing partials. ActiveJob is going to do a tremendous amount of work by loading several hundreds of items at once, and then when it's ready, passing that data back to the front end out of band over ActionCable. So ActionCable and ActiveJob are going to work really well together to keep the perceived main thread open so that this page load feels very snappy. And then finally, Stimulus will add the interactivity so that everything that doesn't need a server-side request feels like it's happening on the browser side. So that's it. I hope you have some ideas of how you could speed up your own Rails application, even if you're not building a progressive web app. I think the principle of not blocking the main thread is a good idea to keep in mind no matter what kind of experience you're giving to your customer. Progressive web apps could even replace an Android app now, especially since they have support for notifications, and they're getting first-party support on Android, if not now, in the next release. And that's actually pretty good because the TurboLink's Android wrapper is kind of in a state of limbo. So if you're looking to change something from that, you could use a progressive web app and not have to worry about a native Android app, depending on what you need. And then even if you don't need notifications, you could look into replacing a native iOS client too. So thank you very much. You're now able to cut through the front-end fog and keep it Rails when building a progressive web app. Thank you.